All right, this is the solution to 3.4, number 93. There are two parts to this. We're going to prove using the chain rule that the derivative of an even function is odd and derivative of an odd function is even. The very first one's not too bad. We're going to go ahead and start, be pretty rigorous here. We're going to let f be even, which therefore by logical deduction or by definition, this will imply that f of negative x is the same thing as f of x. And now we can say, taking the derivative of both sides, we get derivative with respect to x of f of negative x, that's the derivative of the left-hand side, and that is equal to derivative with respect to x of f of x. Well, we get the following by chain rule, maybe I should say, by chain rule. The right-hand side there, or I'm sorry, the left-hand side, derivative with respect to x of f of negative x is equal to f prime of negative x times the derivative of that negative x, which is negative 1. So negative f prime of negative x. Thus, the left-hand side can be rewritten as the negative f prime of negative x. The right-hand side is just f prime of x. And so we get the following, that f prime of negative x is equal to a negative f prime of x. Hence, f prime is odd. And we're going to take that same approach where we say, we assume the precedent here that on part B that the derivative of, or that we have an odd function. And then we're going to write the result of that. And then we'll take the derivative of both sides. And we'll just notate that. So that's all we did here is we just notated. We're taking the derivative of both sides. And then we're going to change out what that left-hand side is. So here we go. Part B. Assume that g is odd. What does that mean? That'll mean that g of negative x will turn into negative g of x. And we can take the derivative of both sides. This time I'm just going to write an implication that derivative with respect to x of g of negative x is equal to the derivative with respect to x of negative g of x. And I'll write that in brackets because that's really bad notation to leave it like that. And I'm going to tell the world, because they may think that I tried to use the chain rule there. I actually did not use the chain rule. I'm going to tell the world that taking derivative of both sides. Take derivative of both sides. And again, this is so that notationally somebody doesn't think that I just tried to take the derivative of g of negative x, because they would have said, well, you need to use the chain rule there. And so now I'm going to say, but by the chain rule, the derivative with respect to x of g of negative x is going to equal g prime of negative x times the derivative with respect to x of that negative x, which is a negative g prime of negative x. Okay. What does this mean? Well, that means that I could trade out the left-hand side for negative g prime of negative x, and I could trade out the right-hand side of this right here for the g prime of negative x. Or I'm sorry, for negative g prime of x. I don't know why I said that. For negative g prime of x. Multiply both sides by a negative, and you get g prime of negative x is equal to g prime of x. Hence, g is even. Okay? And that's exactly what we want to show.